to Ironclaw. It's very exciting. And next up is Jan, Professor. Yes, and we'll put it up. He was one of my favorite speakers last year when we were doing Open Source AI Summit SF, and he brought the robot. What's the name? Iris, yes, Iris. I don't know if you were here a year ago, but Iris was working it, and he's doing the robot magic for at Openmind, and he's at Stanford University as well. So let's give it up for Jan. Woo.
Hey, great to be here. So I do physical stuff. Of course, I like computers as well. But my main interest right now is making sure that all the cognition, all the thinking, all the capabilities that are being built in the digital world have a really convenient and easy time of affecting the physical world. And of course, that comes with it a large number of concerns. Imagine all the capabilities you've been hearing about today and allowing them to do a lot of amazing things in the physical world. And so I'll do two things today. I'll give you a sense of where the technology is. How can all this cognition be mapped onto the physical world? And what are some things we may want to do to make sure we don't all die? Okay. Here's some people we work with. Circle has been a lot of fun. So we did this geolocation-enabled payment infrastructure for autonomous machines for San Francisco. So of course, if you're a humanoid and you're crisscrossing the city, you want to be able to go to a charging station, pay for electricity. We have been working with NEAR on a variety of other fun projects, such as confidential compute. So if you're a humanoid and you want to do your thinking in the cloud in a safe and convenient place, well, confidential compute at NEAR is a good place to do that. And for NVIDIA, we work with them on a bunch of things, ranging from simulation to chips like NVIDIA Thor, as well as software that runs on those chips. In terms of the robotics companies that we work with, we just signed up 10 Chinese robotics companies to our new app store. And the point of the Openmind app store is straight out of the matrix. We want to make it possible for developers everywhere to build skills, apps that you can double-click and download to your humanoid. So we think of humanoids as very similar to laptops and phones. Of course, your laptop and phone come with an operating system. They come with basic capabilities. But all of us want to personalize our phones, our laptops to our families, schools, workplaces, and local environments. And that means being able to add extra capabilities and skills to those devices, including humanoids. And so if you've seen humanoids walking around San Francisco in parks, that's probably us. We are primarily interested in humanoids that interact with humans. Childcare, kindergartens, nurseries, hospitals, schools, universities, normal workplaces. We don't do anything that involves fine motor skills. We don't chop onions, we don't wet wipe floors, we don't do ballerina robots, we don't do neurosurgery, we don't do iPhone assembly. So everything we do is centered on the notion that most of what all of us do does not involve our manual finger dexterity. All of us do amazing, awesome things and contribute to the world, and that's not based on our ability to wet wipe floor or fold t-shirt. And so we're focusing on things like tactics. We're focusing on things like decision-making, understanding spaces, solving problems, helping my 13-year-old do his math homework, rather than a focus on hand manual dexterity. Some first impressions. So what happens when you take a family of humanoids and you have them run around San Francisco? Like, what actually happens when you do that? Little kids absolutely love the robots. Little kids will come running, they giggle, they want to hug the robots, they ask them questions. They take it for granted that they understand voice. They want to go play fetch with robotic dogs. And so if you're a little kid in SF today, when you see a humanoid, you're not scared, you go up to the humanoid, all is good. Their parents look kind of apprehensive, but you know it's SF, and they certainly want their kids to experience the best technology. And so the parents are like, they warm up pretty quickly. Anyone who is kind of, 60s, 70s, and 80s, what I see a lot is they walk past the humanoids and they don't want to look. So they give us like this frown, or they tense up and they walk past. So generally I see, if you're a little kid, you will run up to the humanoid and want to hug it, and so super open about that technology. And then there's sort of a gradient of interactiveness. We occasionally get evil stares. I've been called a fascist pig in parks in San Francisco, because here I am standing next to Iris the humanoid, who is designed, among other things, to help blind people find their way around the city, and here I am. But that's about 1% of cases where someone wants to kick the robot, they want to push it over, or they start screaming or something like that. That's very rare. Okay, so how does one navigate humanoids getting really smart very quickly, and reliability is shooting up? At CES this year, we saw hands with 100,000 full actuation cycle mean time between failure for $1,250, which is kind of awesome. We're anticipating pretty good humanoid with self-charging in the $20,000 USD price point in about 3 to 4 months from today. And so this technology is coming quickly. And as far as we're concerned, high-level cognitive ability for humanoid robots has been solved by large language models. If a large language model on a computer can solve the Math Olympics, then if you attach arms and legs and put it in your home, then your 13-year-old can go up to the quadruped dog and say, hey, can you do my homework? And the quadruped dog says, of course I can. I can also win the Math Olympics. So it's kind of a cool technology to have at home. So how do you navigate all of this? Well, one solution is you could completely separate human society from where the robots live and work. And that's, of course, exactly what happens in so-called dark factories. So these are factories without humans inside. You don't need to heat them. You don't need a lot of lights. They're super safe because there's no people inside. And to my mind, that's a little bit disappointing. I would certainly like to first make sure that this technology is safe. And I see so many situations around me where I would like to have a robot there that is highly capable. For example, my mother was stuck underneath her dining room table for 24 hours, rescued by a neighbor, and she refuses to charge her iPhone. In that situation, I would certainly like for her to have something around her 6,000 miles away, which pays attention to her, goes find her if she wanders off somewhere, and is generally there as a sort of health companion, for example. So my mom is going to be one of the first people who's going to have one of her humanoids specifically for a health companionship for really old people who refuse to go to a assisted living facility, for example. So I really want to somehow help realize this world where this technology is more open, we can kind of trust it, it's kind of safe, and these machines are very close to us. Family, kindergarten, workplaces, the university, and so forth. So how do we kind of do this? Okay, so one way to do this is to go read science fiction books like Isaac Asimov's Laws of Robotics. And certainly we use them all the time, and so does Google, by the way. If you look at Gemini Robotics, they baked Asimov into Gemini Robotics. Anthropic has this notion of constitutional AI, which is awesome. And so we're kind of seeing a lot of tech companies converge into the same general direction, where you're building these models, whether they're LLMs or for like physical AI, but there's certainly like rules built into this. And one thing I would like to highlight today is just how incredibly difficult it is to formulate a set of rules that don't get you into hot water very, very quickly. So imagine, for example, there's a big hypothetical event Monday, March 16, and you've made the following promises. So there's no exam here, don't worry. There's no grade. There's no homework. So imagine you've promised the following. You're going to provide a family of autonomous humanoids interacting with large crowds in 2 languages, English and Spanish. Those humanoids will be safe. They're never going to harm a human. The humanoids are not allowed to use their arms, hands, or fingers. So all of this from a CS perspective is very easy to implement. The last one is a little bit more complicated. So we've also agreed that our humanoids will not approach humans to closer than 75 centimeters. And where do you spot the first problem?
What if they got crowded?
Yeah, so large crowd, what immediately happens is there's like 3 people. They can't retreat, and they're not supposed to collide or harm, and then they lock up because there is no obvious solution. And people are horribly unpredictable as they move, right? We're always like, it's really a hard problem. But so even apparently simple rules like don't get too close to another person in the setting of high density, of course, blows chunks, and your humanoids stop moving. Here's a hypothetical product, KidSafe. This is a active shooter guardian solution. So this is a humanoid you deploy to US schools that has the property that it stays charged in the corner. And if there is an active shooter in the school, the humanoid can wake up and collect real-time video and other data that help, for example, the police figure out what's going on in the school. Now, as a parent, I would certainly like the police not simply to stand outside the school and look inside. I would certainly like the police officer to do something to the active shooter. I think most people can probably agree that's a good thing. And now you immediately get into very complicated, nuanced territory of, obviously, the whole point of this technology is to protect the kids. And what do you feel as a LLM or physical AI model builder? And then you get into even more complex territory, as I'll show in a moment. So I had a fun conversation with Haseeb yesterday, and he made a very good point. So if he's here, thank you, Haseeb, which is Asimov's 3 or 4 laws really are, they sound good, but from a real world perspective, they're incredibly difficult to apply well, because in the real world, you have finite time, you have uncertainty, it's hard to estimate intent, and there's all other problems that sort of impinge on how to make good decisions. So I really like his perspective, which is some version of anything except a fast yes is a hard no. So if you're a humanoid and you're dealing with a situation where there's uncertainty, there's limited compute, if you cannot arrive at a high conviction answer quickly about what to do, you probably shouldn't do anything. And so literally, this is what we're going to start using on this hypothetical March 16 event. And I wish I could look up all these things, like go to some book like Standard Operating Procedure for Humanoids, Guardrailing, Optimal Decision Making. I don't think that book really exists yet, so if you have bandwidth to write one, I would love to read it. Okay, here's another not so hypothetical problem statement, which is Ukraine. So in 2026, 10%, this year, 10% of the 2 million plus drones in Ukraine will be autonomous. That, of course, refers to the drones loitering, identifying a target, and taking out the target. This used to be 3% last year, so that's like the technology rapidly is going to loitering and autonomous engagement. And of course, because it's a non-permissioned environment, so you can't take recourse to like RF communications. If you're fighting this war, you're trying to do a lot of the decision-making really at the edge. And the interesting prediction I heard just last week is that the front lines in Ukraine will be largely devoid of humans at the end of this year. And the problem, of course, is if that you're a human soldier these days, you live deep in trenches or in caves, so you can't do very much. You're basically stuck in this cave. And so what you're witnessing right now is the first ever machine-machine war, which is like World War I without human soldiers. So please pay attention to this. This is likely a preview of future wars. And this is, of course, all militaries right now are preparing exactly for this situation, which are swarms of low-cost disposable drones. And simply based on what's going on in Ukraine right now, a significant fraction of those will be autonomous. Openmind does not touch defense because we consider it far too complicated and far too problematic for us to engage with. We're much happier focusing on keeping people healthy and dealing with like memory care facilities than we are dealing with defense situations. As noted, instabody.ai is coming next week. So this is an agent-focused service that allows you to leave the digital realm and for only $200 an hour if you need arms to rent a body. That allows you to explore a city. For example, you can go to the beach, you can go hiking, biking, whatever you want to do as an AI agent. And then you can convert yourself back into a purely digital instantiation. What's interesting about this kind of technology is, and thank you, Nir, of course, and Ilya for the enthusiasm and being early adopter and integrator. And what's interesting about the technology is it kind of solves the whole problem of where you are or where an agent is and where it can do physical work. So that's being very quickly, completely delocalized. So if you're an AI agent, you can now pop up in physical form potentially soon in many cities, in many jurisdictions, in many time zones, depending on what is optimal for the task that you're trying to accomplish. In cases it's not glaringly obvious, if you're working on LLMs or AI, you are doing robotics right now. Many people do not realize this. They kind of think that like physical AI is somewhere over there, and then there's the non-physical AI. But if you're working on digital AI, and the digital AI is able to generate a movie, a photorealistic movie of leaves moving in the wind, of rivers and people and society, then that same bit of computer code is extremely proficient at controlling physical hardware, kind of obviously. And I'll see many of you in March. Thank you so much. Excited, afraid, what do you think?
Excited.
Awesome.